Let's talk about each of the sensors in a little more detail, starting with the accelerometer. The accelerometer measures lateral movement of the phone in any direction, represented by three axes, X, Y, and Z. The accelerometer is a piece of hardware inside the phone that measures this motion. Now, technically, it doesn't measure movement directly, it measures acceleration. So what this means is the phone can tell if it's been moved in a certain direction by seeing if it's accelerated in that direction. But it can't tell how far it moved in that direction just from the accelerometer data. To understand how the accelerometer works, imagine a box with a little metal ball suspended inside by springs attached to all sides. And if you imagine this box is stationary, the little ball inside is also stationary, and each of the springs are stretched a certain amount, but nothing is moving. If you move the box in one direction or another, or picked it up, some of the springs would start to get stretched out more than the others. By measuring how those springs get stretched by different amounts, you could measure how much the box is accelerating. Now, the phone doesn't actually have a tiny box with a little metal ball inside attached with springs, but what it does have is not actually that different. It's smaller and it's made of silicon. There is one part that is fixed rigidly to the phone and another part that is more or less free-floating, and these pieces move relative to each other when the phone accelerates, and the phone can detect that. One interesting point about the accelerometer is if you picture the box sitting on top of a table, the spring connecting the ball to the top of the box is going to be stretched out a little more than the spring connecting to the bottom. And if you flip it over, those springs are going to reverse. What this means is when the box, or the phone, is totally stationary, it doesn't actually measure zero acceleration in all directions. It measures the force of gravity. The only time it will measure zero acceleration in all three dimensions is if it's in free fall, like if you dropped it out of a plane or something. So because the phone can detect the force of gravity, it knows which way is up, which is how it does things like flip the screen around, like when you're looking at a picture or a web page or something and you flip the phone over. After a moment, the image flips around so the image is right side up again. The way the accelerometer works from an app's perspective. When an app wants to start using data from the accelerometer, it tells the phone that it wants to start using accelerometer data, and the accelerometer starts passing the app updates at given intervals with new data at each interval. And then the app can process those updates or save them and process them later or do whatever it wants with them. The accelerometer is extremely sensitive, so any amount of movement at all will be picked up. Even if you're holding it in your hand and you think you're holding it stationary, the accelerometer will pick up any small movement that's happening. This means the signal from the accelerometer is extremely noisy because you get all these tiny little movements included even if you're only interested in the bigger movements. The accelerometer response rate is also extremely fast. The accelerometer can provide updates to an app as many as 100 times a second. What all this means is that it's pretty difficult to work with the accelerometer data directly because there's so much data involved and the data is so noisy. So to process the signal tends to be pretty complex stuff. Luckily, most apps don't have to access the data directly. They can access data that's been packaged up by the phone into certain useful pieces.